Welcome everyone, I am Ujjwal Pat. Today we will solve a LeetCode problem step by step. The problem number is 1105, which is filling bookcase shelves. Let's see the problem description. You are given an array books where book size is thickness and height, and indices indicates that thickness and height of each book. You are also given an integer which is shelf width. You want to place these books in order to bookcase shelves that have a total width of shelf width. Okay, and we choose some of the books to place on the shelf such that the sum of their thickness is less than or equal to shelf width. Then build another level to the shelf of the bookcase so that the total height of the bookcase has increased by maximum height of the books we just put down. We repeat this process until there are no more books to place. Note that at each step of the above process, the order of the book we placed is the same order as the given sequence of books. For example, if we have an order of list 5 books, we might place the first, second onto the first shelf, the third on the second shelf, and fourth, fifth on the third shelf. And return the minimum possible height that the total book shelf can be after placing shelves in this manner. So what the problem says that we have to return the minimum height that could possible after arranging all the books in a cell, and the width of the cell is given, like you can see in this image. The width is this, the width is given, and we can arrange the books. We do not uh, change the order of the books, like one, then we have to place the two, then we have to place the three. And second one is we have to minimize the height. Okay, you can see one, we can place the two here, like there is enough space to place the two, but if we do so, then the height would not be the minimum. So you have to place the two in the second shelf so that the height could be minimum. And after placing one shelf is completed, then we do not add, like after adding two, we have to imagine a line that we could not cross. Like after two, there is like some space could remain. We could not use the space because we will like place uh, a level that is a level. Like you could not use that space. Okay, so this is the problem, and how we will solve this, I will explain you the algorithm. First, think that we have only two options. Either we can place the current book in the current in the current cell, uh, like cell with okay, so either we can place the current book in the current cell, or it will be placed in the next cell. Okay, either this or otherwise on the next cell. Okay, there is only two possibilities. So, and whichever will be minimum, we will take that. And for each of the book, we will place uh, like uh, first try to place the book in current cell, and try to place the book on the next cell. Whichever will be minimum, we will take that, and we will do, if the current book is can be placed in the current cell, then we will do the process until the, like we are given the self width. So until the self width is reached, like in the current cell, we will do for each of the books. Like we can be placed 4 books in the current cell, so we will check for 4 of them, like it can be put in current cell or next cell, and calculate the minimum height for both of them, and after which we will give the minimum, we will return that as an answer. Okay, this will be the algorithm, and you can imagine that it will be like we have to store the calculated answers, because after it, like there will be some cases where we will use the same uh, like we have to calculate the same thing again and again, so we will use dynamic programming here. to store the results of the like each of the index so that we do not have to calculate them again and again. Okay, so first I am taking the length as books dot size, and we will create a vector of integer. It will be dp of size and initial it will be -1. Okay, and we will make a function and return like helper function, which will take the books and self with dp. Current index will be 0 and the length will be n. Okay, and it will, the helper function will return the minimum height. Okay, so let's make the helper function. First it will take books. I'll write the books as b because of do not write to need to like write books again and again, and the self width as just width, and then we have dp, and we have to use the reference because if we do not add this ampersand here, so every time we call this function it will create a new dp. We do not want it, we want only one, so we will use the reference so that in every function we change the dp, it will reflect all like all in all functions it will reflect the same result, so that we will use ampersand, and then the current index, that is I, and int n is the length. First we will check if I is equal to n, that means we have already like we have already finished the traversing all the books, so we will just return the minimum height as 0. Okay, second we will check if dp of I is not equal to -1. That means if we already have calculated the answer, so then just return the answer. dp of I will be the answer. And if not, then we will calculate the minimum height against like all possible ways. Okay. So first I will make a main height. MNH means minimum height, and initially I will take it int max. Second, we need the current height, because every time there would be like books height which will vary, like one or two, their height will be uh, like uh, like not all heights are equal, so we need to keep track the current height, or you can say the current maximum height. Okay, so let's say current max height. Initially it will be 0, and we need the current width. Initially current width is 0, because we have to check that the width value do not exclude, like we have to place all the books so that the maximum height will be less equal to the given width of the cell. Okay, we need three things. Now for, let's say, all index is I, current index is I, we will traverse while the index is less than n, and the current width is less than equal to the width. Okay, first we check if the current width plus the current book width will be book of I, and width is the thickness, that means the first one, which is 0, is less equal to width or not. If it is less equal to, let's say, not less equal to, let's say it is, if it is greater than, just break it. Okay. Otherwise, calculate like current width. Current width will be plus equal to b of I0. Current width will be increased, and we have to calculate the current height also. So current height, current max height will be maximum of current max height and the current book height, which is b of I1. Okay. Next, we have to calculate like if we do not place the book in current cell, if we place the book in next cell, what will be the uh, like minimum height. So first next, let's say next book. For next book, it is same helper book width will be the same, and dp I will be I plus 1. For next book, we are not placing the next book in the current cell, we will place it in the next cell, and we will calculate the like height, minimum height for that, and the name will be the same. And we will also add the like it will give, this function will give the minimum height for the I plus 1 to n books, and current height is we have to add it the current height, so that we get the whole height, like for placing all the books 0 to n minus 1. So we'll get after this the next book height is the minimum height from all for all the books. Okay. And we will keep track of that. MNH equal to minimum of, MNH is the global minimum height, okay, which will keep track from 0 to n all the books. So it will be minimum of MNH comma next book height. Okay. And after that we will I plus plus, that's it. Not I plus plus, IND plus plus, because IND is the index we are working with. Next we just need to return the minimum height, like minimum global height, which is MNH. So let's see, will it work? Okay, there is wrong answer, because we have to return here, we need to keep store the dp of I here equal to MNH, because we need to keep track the answer also. And the other thing is like, okay, we are using index here, but we are not. So all the I will be index, because we are currently working with index here in the within the while loop. So my bad. This all will be like, not I. All will be index and dp of I. Let's see now it work or not. So it work. Let's submit it. So let me discuss the time and space complexity of this algorithm. So the time complexity will be, we are like the recursion function will be goes from like we are checking for last, like from 0 to n up to n time, because after n time it will return 0, so it will goes from 0 to n minus 1 time to, and for each of the iteration or each of the element, we are going from up index to up to n. So we can say the this is a nested loop. So the time complexity will be big of n square, because the recursion function is goes n times, and for each of the element it is going from I to less than n. So we can say the overall time complexity is big of n square. And for space complexity, we are storing using a dp to store the answer for each of the indexes. So the space complexity will be big of n. So that's it for today. See you in the next video.